Hi everyone and welcome back to my channel A in Economist. So today we are going to talk about something called a dummy variable, which is a very interesting concept in econometrics. We will understand the concept with the help of examples. We will formalize that and we will see what are the types of dummy variables that are present in the model, right? This is going to be our lecture number 24. I have made a detailed playlist on econometrics before. If you haven't watched that video, if you are new to my channel, I would recommend you to do so. Please check that out. And I'll give the link in the description. I'll also give it in the I tab button. So check that out before going into dummy variable. So what is dummy variable? If you remember, as of now, the analysis that we have done, whether it is of classical linear regression model, whether it is multiple linear regression model, we have only talked about quantitative variables, right? We have only talked about quantitative we have only talked about quantitative variables. Quantitative means what? Which you can represent using numbers, right? We have only talked about variables which can be represented using some numbers, right? So, for example, the years of experience, you can exactly measure how many years of experience do you have, right? So, this will be one of the quantitative variables. Or suppose your age. Age is a quantitative variable, weight is a quantitative variable. So, all these variables that we have talked about so far is quantitative in nature because you can explicitly put numbers to express those variables. But what if you want to measure the impact of qualitative variables in your model, right? It may be so that suppose you want to measure the salary of a person based on the gender, right? You can measure the salary of a person based on his or her gender, or it could be based on his or her race, or it could be based on the religion. It could be based on the religion, or it could be based on the language that he or she speaks, right? So these are certain qualitative variables which can also be present in your model, right? These are certain variables which could also be present as an explanatory variable in your model, which you cannot quantify. Can you quantify the gender? The answer is no. Can you quantify the race, religion, or mother tongue language? The answer is no. You cannot quantify them. That is why they are the qualitative variables. They are the qualitative variables. And if you want to measure the impact of qualitative variables in your model, then you need something called the dummy variable, right? Dummy variable helps you to measure the impact of qualitative variable if they are present in your regression model. So let us understand this with the help of an example. Let me give a very small example. Suppose we want to find out, suppose we want to find out the income we want to find out the income of a college teacher, the income of a college teacher based on gender. Based on gender, so basically we are taking male and female here, right? So gender is, as I have told you, this is a qualitative variable, right? Gender is a qualitative variable. It can be male, it can be female, it could be other as well, but we are taking male and female for simplicity in our particular example. Now, what we have to do is that for quantifying this, for representing gender in your model, what do? You take up a dummy variable. Suppose D is a dummy variable, and I assign a value 1 to it if the college teacher is male, and I put the value 0 for female. This is how you introduce dummy variable in your model. So dummy variable is usually a binary variable where what we do, this is how we quantify the things. It will take the value 1 if something happens, it will take the value 0 if the other thing happens, right? So in case of gender, I have assigned, you can take it the other way around as well. D can be equals to 1 for female and 0 for male. Any which ways, any ways you want, you can assign the value. Now, if this is the case, then Let us define the model as this. Y equals to, the model is suppose alpha plus beta into the dummy variable plus ui. Suppose this is your model now. So can you tell me what is this expression? Can you tell me what will be this expression? Expected value of y given d equals to 1. Can you tell me what will be this expression? So this basically y represents the income of the college teacher, and it is based on the gender. This is the simplest model. If we do this, expected value of y, that is the expected income given that d equals to 1. Given d equals to 1 means given the college teacher is name. So from this model, can you say what will be this? Simply put, instead of d, put the value 1. So what you will get? You will get the value to be alpha plus beta, right? As simple as that, you will get the value to be alpha plus beta. And what about this? Y given d equals to 0. If you do this, what will be the value? If you put d, the value is 0, then it will be simply alpha. Right? I hope up till this much, this is absolutely fine. That expected value of income when the person is male will be alpha plus beta, and expected value of the income when the person is a female will be simply alpha. Right now, what can you say? How will you compare this to expected level of income? How will you compare everything? See, everything depends on this parameter beta here. So, if this beta parameter is strictly greater than 0, then what you can say is that the average male income will be strictly greater than the average female income. So it is on an average. So this average word is very important here. We cannot say absolute value. We cannot say, we can only find out the expected value. Now, if this beta is exactly equals to 0, what can you say? The average male income will be exactly equals to the average female income. And if this beta, suppose it is less than 0, then the average male income will be strictly less than the average female income, right? So this will be a simplest example of the dummy variable. So see, expected value. These are the two things that we have found out from our model. This is our model. Y equals to alpha. Alpha is a parameter, beta is another parameter, but the dummy variable is present in your model. In the multiplicative form, dummy variable is present in your model. It can either take the value 1 or it can take the value 0. If you take the value 1, in our case, it represents a male college teacher, then his average income, his average salary will be alpha plus beta. Whereas if you consider a female college teacher, then the value of D will be 0 in our case, then expected income will be alpha. Now, how do you compare between the salary of these two college teachers? So everything will depend on this parameter beta here, right? Everything depends on beta. If beta is greater than 0, then average male college teacher income is greater than this female college teacher income. If beta is 0, then they are equal. If beta is less than 0, then the average male college teacher income is less than the average female income, right? So I hope this example is very clear and you got to know how to introduce dummy variable in your model, right? Now let us take a concrete example and see how we can formalize this entire concept in a better fashion. So for that, let us take a fresh example. Let us take a fresh example and let us introduce two or more dummies in our model. So see this example. Suppose we have, suppose we have n states divided into three regions. Suppose this is just for an example, I am considering this. Suppose we have n states which is divided into three regions. What are the three regions? The first region is the northeast. First region is the northeast region. Second region is the south region. And suppose the third region is the west region. Right? So region is again a qualitative variable, right? You cannot quantify regions. So what you expect is right that we have to introduce dummy variable in our case. So the question is, suppose yi denotes the salary of teachers in the state I. In the state I. Now the state can vary between 1, 2, and 3. Basically, sorry, not 1, 2, 3. This in states, basically 1 to n. The salary of the teachers, yi denotes the salary of the teachers in the state I. And we consider the regression model. Our model looks something like this. Yi, say it is beta 1 plus beta 2, and then we will introduce the dummy variable d2i plus beta 3 d3i plus ui. Now let us define the dummy variables, where this dummy variable d2i will take the value 1 if state if the state belongs to the northeast region. If the state belongs to the northeast region, and it will take the value 0 otherwise. So if the state belongs to south region or west region, then this dummy variable d2i will take the value 0. This is the first dummy variable, and let us define the second dummy variable as well, d3i. This is another dummy variable. It will take the value 1 if the state belongs to the south region, and it will take the value 0 otherwise. So for northeast region and for the west region, this dummy variable d3i will take the value 0. So here d2i and d3i are nothing but dummy variables, right? They are the dummy variables. Now, see one thing, observe one thing, that we have three categories here. This is the first category, that is the first region. This is the second region, and this is the third region, right? We have three regions, that is three categories of regions. But here we are introducing only two dummy variables, right? Three regions, but we have introduced only two dummy variables. This is the same thing that we have seen in the previous example also. See, here the qualitative variable was gender, and there are two categories of gender that we have taken under consideration. One is male, another one is female. But while introducing the dummy, we have only considered one dummy variable, not two dummy variables, right? So what we can see is that the number of dummy variable introduced will be one less than the total number of categories that are introduced, right? This is one of the most important properties, and it has a very important implication that we will go into the next video. We will talk about that. If you introduce the same number of dummy variables as the as the total number of categories that are there in your model, then you will face something called the dummy variable trap, right? Then you will face something called the dummy variable trap that we will talk in details in the next video, right? So as of now, just observe this thing, that yes, there are three categories, 1, 2, 3. There are three categories in our model, but we have only introduced two dummy variables, namely d2i and d3i. These are the two dummy variables. Now again, we will do the same thing. We will try to find out the expected income, right? We will try to find out the expected income. Let us do that. So what will be the expected value of yi given d2i? Suppose d2i is 1 and d3i is 0, right? If d2i is 1, d2i 1 means that the state actually belongs to the northeast region, and d3i 0 means it is belonging to northeast region. Basically, that is why d3i is 0. Right? If d3i will take the value 1 if the state belongs to south, which is not the case here. That is why it's taking the value 0, and d2i is taking. So basically, it represents the average salary of teachers in the northeast region, right? Average salary of teachers in the northeast region. So from this model now, let me remove this lines. So from this model, this is our original model. Here, if you put this d2i to be 1 and d3i to be 0, then what will you get? What will be this expression? This will come out to be beta 1 plus beta 2. see here, beta 1 is there, beta 2, because this is 1, so this beta 2 will be there, and D3 is 0, so beta 3 will automatically be 0. So it will be simply beta 1 plus beta 2. And the interpretation, as I've told you, let me write it down. This represents the average. So this again, this average word is very important, so don't skip this word. This is the average salary. This is the average salary of teachers in the northeast, northeast region. Right? In the similar way, what you can do, you can find out this expression. Let me go to the next page. Expected value of yi given D2i is 0, but D3i is 1 this time. D3i 1 means what? The state belongs to the south region, and automatically D2i becomes 0 then. So if you find this, what will be this expression? This will come out to be beta 1 plus beta 3. You can do it on your own. I hope you got the process. Now this will give you the average salary of teachers in the south region. Right? This is done. Now there is a third thing. Expected value of yi. Suppose both the values are 0. Suppose both the values are 0. What will be this expression then? If you look from the model itself, it will only come out to be beta. It will only come out to be beta, and this will give you the average salary of teachers in the west region. So we have not introduced any dummy variable for the west region, right? We have only introduced dummy variables for the northeast region and for the south region. We haven't considered anything about the west region. That is why if you put both the dummy variables to be 0, you will only get the intercept term. And later on, we will define it formally. Then this intercept term will be known as the benchmark category. This value for which the region for which or the category for which we have not defined any dummy variable, we have not introduced any dummy variable, will be known as the benchmark category, which is given by the intercept of this model. Right? Now this much is done. Now if you know this thing, then can you tell me how will you find out the value of beta 2 from this model? From these three expressions that you have. So this is the first expression that you have. This is the second expression that you have. This is the third expression that you have. From these three expected salary values, can you find out the value of beta 2 somehow? Can you find out the value of beta 2? If you try to find out, you will see it will be the difference between the expected income when D2i is 1, D3i is 0, minus the expected value of yi when both the dummy variables are 0. Right? So if you see this, we have got as beta 1 plus beta 2, and now this will be simply beta 1. So if you cancel this out, you will simply get the value of beta. Right? And in the similar fashion, if you try to find out what is the value of beta 3, you will see beta 3 will be the difference between yi given d2i equals to 0, d3i equals to 1 minus the benchmark category when both are 0. Again, the similar logic, see, here it will be beta 1 plus beta 3, and then you have only beta 1, so this beta 1 will cancel out and you will end up with beta 3. Right? So here this slopes, that is beta 2 and beta 3, will give you how much the mean salaries of teachers in the northeast and in the south differ from the mean salaries of the teachers in the west respectively. So Let me write it down. The slopes, namely beta 2 and beta 3. So this is basically the interpretation of slope in the dummy variable concept, right? So this is the beta 2, beta 3 are the slopes of the original model. This is the slope coefficients basically. So this is the interpretation of the slope coefficient when dummy variable is present. So see the slopes beta 2 and beta 3 gives how much the mean salaries, mean means average, mean is the average, mean salaries of teachers in the northeast and in the south differ from the mean salaries of teachers in the west respectively, right? So this will be the interpretation of the slope coefficients, and here the region for which no dummy variable, no dummy variable is introduced, no dummy variable is introduced, that is the west region, is called the benchmark, is called the benchmark category, right? This is known as the benchmark category. And how do you interpret the other two things? Let me do that as well. Here, the coefficients attached to the dummy variables, namely beta 2 and beta 3, are called the differential intercept, differential intercept coefficient, because because they give by how much the values of that of the intercept that receives that receives the value of 1, differs from the intercept coefficient of the benchmark category, right? So this will be the interpretation of the intercept and the slope terms in the presence of dummy variables. So please remember these two things, that what is the differential intercept coefficient and what is the benchmark category in the context of dummy, right? This is all you need to know about dummy variable. And then we have a small concept called the interaction dummy that I'll do, and then I'll finish this topic. So let me do that as well. So as of now, you can basically take a screenshot of these two things, and this will come handy when you try to solve problems on dummy, right? The final thing is the interaction dummy. Interaction dummy is also known as the slope dummy, right? So again, we will try to take the same example and try to see what we are saying about this. So suppose we want to find out, we want to find out the income of a college teacher, income of a college teacher based on gender again. So basically we are taking male and female for our example. So we will introduce the dummy variable once more. So one for say male, and it will take the value 0 for female. Now suppose we change the structure of our model. Suppose we take the model as this now. Model is yi equals to alpha plus beta x plus gamma, the dummy variable, and then you have another term delta into x into d plus v. Suppose this is the new model. Now this is an interesting sort of model. We have not worked with this kind of model before. So try to understand this. So this is the salary of the college teacher, right? Salary of the college teacher. Now X here represents the number of years of experience. X is the explanatory variable. Explanatory, explanatory variable, which is a quantitative variable. So we have taken this to be the years of experience. Years of experience of the college teacher, right? So this basically we can quantify. This is a explanatory variable which we can basically quantify. This is basically representing the experience of the college teachers. Now D is the dummy variable here. Now see, this is the interaction. This is the interaction of the experience and the gender, right? Here we are making an interaction. So this is in the multiplicative form. Multiplicative form always gives you the interaction, right? So X into D, we have deliberately introduced this term in order to depict what will be the interaction done, right? So this will be an example of interaction dummy where we want to know what is the effect of this interaction of experience and the gender, right? Experience and the gender. One is the quantitative variable, one is the qualitative variable, and we want to know how these two variables interact with each other. That is why we have deliberately introduced this specific term in your model. And this is the new model that we will work with, right? Now, let's do the same thing that we used to do. Find out what will be the mean income. So let's just try to find out what will be the expected income or the average income of the male college teacher. So expected value of y given d equals to 1 and the years of experience. Now see in the model you have an explanatory variable as well. So this x variable is also in the given part. So suppose conditional on. So this sign means the conditional, right? So we are finding out the mean salary of the college teacher given that he is a male college teacher and given his years of experience, right? If you do that, what will be this value from this model? If you see this thing, what will be this? This will be simply alpha plus beta x plus gamma plus delta x. This will be the thing. See, only we have to put this d equals to 1, this d equals to 1. If you put this, then alpha will be as it is, beta x is as it is. Then you have this gamma here, and then you have this delta x, right? That is the entire thing that will be getting. I hope this is absolutely clear. Now, here, what you can do, you can separate out the terms which does not have x, and you can separate out the terms which does have x, right? So this is what you will get, alpha plus gamma, and then you have beta x plus gamma plus, yes, delta x. So you can take this x out, right? So this is how you can write this. Similarly, what will be the expression for y given d equals to 0 and x? So this time we are talking about the female teachers given their experience. Now from this model, if you see, it will only come out to be alpha plus beta x. Can you see this? You have to put this d equals to 0 here, 0 here. So only this term will be remaining, right? I hope this much is clear. So this will be the mean income. This will be the mean income of male teachers, and this will be the mean income of female teachers, right? And what we have seen in here is that, see, if you compare these two things, what you can see is that a very, very important result, that in this case, the slope, the slope and the intercept, the slope and the intercept of this model changes. This is something new to us. So in this model, both the slope and the intercept of this model changes. Thus, the term xd. This is the multiplicative interaction term that we talked about. Thus, this term xd is called interaction or slope dummy. This term is called interaction dummy or the slope dummy. So see, this is the term that we have talked about. This is the interaction of experience and the gender. One is quantitative variable, one is qualitative variable. We are trying to find out the interaction, right? So if you do that, you will see both the slope. Why the slope is changing? Because see, this is beta plus delta here, but here you have only beta. So the slope is changing. And what about intercept? Previously it was alpha plus gamma, and now it is only alpha. That is why the intercept is also changing. That is why both the slope and the intercept of this model changes. That is why this interaction is called the interaction dummy or the slope dummy. Now we can depict this thing with the help of a diagram. So what you will do, suppose here in this axis we measure the x variable and here we measure the y variable. So here x and here you have y. Now firstly we'll see what will be the effect of change in the intercept only. For that, what we can do, suppose we take an intercept. This intercept, suppose this is alpha. So how will you draw alpha plus beta x? What will the expected income of the female college teacher? So it will be simply a line like this, right? It will be a straight line. I am drawing a freehand diagram, so please understand this. It will be a straight line with the intercept alpha. So basically it is measuring y equals to alpha plus beta x. This is that line, which is simply this. The alpha plus beta x, this is the mean income of the female college teacher, right? Now, how do you draw the intercept of the male college teacher if you don't have this interaction, this delta term here? If you don't have this delta term, suppose this delta term, this interaction is missing. Suppose this interaction is missing, then what will you see? You will see the intercept will be increased. How much it will be increased? This portion will be given by gamma. This portion will be given by gamma, and the slope will be as it is. The slope will be as it is. So the slope of this line and the slope of this line will be exactly the same. Again, I am saying this will be two straight lines. I am here drawing a freehand diagram, so please understand that. And the diagram will look something like this. Here the intercept will change. It will be alpha plus gamma, and then the slope will be as it is. So what is the slope? The slope will be beta, right? The slope is remaining the same. See, slope is the same. Only the intercept changes, and this total intercept here will be alpha plus gamma, which you can see here. So if in your model there is no interaction, in your model if you don't have any interaction, then only the intercept term will change, but the slope remains the same. Now see what will be the effect of the slope dummy. In case of slope dummy, both the intercept and the slope will change. So let us start drawing that. So the first line will remain the same. So this red line here, what I have drawn, this will be same for here as well. So this line, so this is again the same thing, y equals to alpha plus beta x. This is for the female. That is the same. But now for the male, For the male counterpart, it will look something like this. It will be something like this. Why this is so? Let me write this alpha here. This is alpha, and now this slope will be what? See from this thing, the slope will be alpha plus gamma. Sorry, alpha plus, yeah, this will be alpha plus gamma, right? Alpha plus gamma. This will be the intercept, and what will be the slope? The slope will be beta plus gamma. So the equation is something like this: alpha plus, this is alpha plus gamma plus beta plus delta into x. So the slope will be beta plus delta, where we consider delta to be negative. That is why the slope is like something like this. Sorry. The delta will be positive. Sorry for that. The slope is increasing, right? So this line in purple is a steeper line than this red line, right? So beta is this, and now if you increase the slope will increase. So delta is will be greater than zero. It was my mistake, right? So this is the intercept now, and this is the slope now. So we consider this to be negative and delta to be positive. Gamma is negative, but the delta is positive if you consider this. So see, both the slope and the intercept changes, and that will be the effect of the slope term, right? I hope I can make you understand this concept. If you still have any doubts, you can let me know in the comment section. I'll clarify that. And this is how we introduce dummy variable into our model in order to handle the impact of qualitative variables into our regression model, right? We have seen how to introduce them and how to use them in our model, and what will be the impact of interaction dummy. If you don't have any interaction dummy, only the intercept term will change, the slope will be unchanged. Here in both the case, the slope is beta. Here also slope is beta, here also slope is beta. But as soon as you introduce the interaction term, then not only the slope but also the intercept changes. So here gamma is less than zero, so that is why the slope falls. The slope is here, sorry, the intercept falls, into intercept is reduced, but the slope is increased since we have considered this delta to be positive, right? So thus both the slope and the intercept changes if you introduce interaction dummy in your model. So this is all from my side for today. In the next day, we'll be talking about the dummy variable trap and why we have to introduce one less dummy variable than the total number of, with respect to the total number of categories that we have for our model, right? So that is what we are going to tackle in the next day. We'll see if dummy variable trap is present, what will be the problems and how we can deal with that, right? So stay tuned for the next video, and I hope you like this video. If you do, then hit the like button and do subscribe to this channel, A Economist, and that gives me immense motivation to continue making such useful videos for you. So thank you for your time, and let's meet you in the next.